electrical class. I want to walk you through a typical air conditioning condensing unit. This is the one at my house. Let me get it open up and I'll show you what's all inside here, okay? Okay, let's take a look at this disconnect first. Let's take the cover off. See my fuses and my pullout for my fuses. Get in here to look at the electrical. It's usually a little tougher to get off, keep people out. Look in here, we can see my two high voltage wires coming in from my circuit breaker panel, L1, L2, and also my ground wire. None of these are properly color coded. That's a problem, but it is what it is. So all the more reason I have to follow these wires so I can see which ones are going where. Power goes into L1 and L2, goes through my fuses. You can see these are both 50 amp fuses, time delay. I'm able to put this in one direction. See, it goes in real easy. That is in the off position, or turn it around. It takes a little bit more to push it in. I'm now in the on position, so all the power coming in goes through my fuses and into through the conduit and up into my unit. Okay, up in the control panel side, I've got my dual capacitor. Looking at the specs on the side, it looks like a 60 microfarad for my compressor and 5 microfarad for my condenser fan motor, making it a dual capacitor. My low voltage control wires coming in, two blue wires going right to my contactor. I don't have any safety controls in this unit, so they just go directly to my contactor and energize the coil on my contactor on a call from cooling from my thermostat. My L1 and L2 are coming up, coming into my contactor, and my ground wire going over to my ground connection connected to the chassis on the unit. Also want to take a look at the schematic for this unit. Pretty simple. Show my high voltage wiring coming in with the dashed lines. My dark thicker lines are my high voltage. All the thinner lines, thinner solid lines are my low voltage. Pretty simple. It looks like a optional high pressure switch, optional crankcase heater with a temperature based switch to open and close that and energize or de-energize that. Neither of these options are in here. Start capacitor, looks like a potential relay. None of that is part of this unit, but they are options, just not included. I've got my legend over on this side, explains what all the acronyms are. You can see my start winding and my run winding for my compressor, and the thermal overload inside my compressor. All right, this is how I like to do start and test on a piece of equipment. Instead of going up to the thermostat, starting the unit, coming back down here, I've lost the first 30 seconds to a minute of the unit operation. And sometimes it's critical when I'm trying to diagnose a piece of equipment. So I'll come down and I'll disconnect the control wiring down here, go turn on the thermostat, come back down here, get ready so that I am in full control when I want to operate this unit. I'm going to put my meter on. I'm going to set it to the 40 amp scale so I can watch the amperage draw when this unit starts. I've got my jumper. Put it on one side of the wire, and when I connect back to my other side of the wire, the unit's going to start. I'm going to watch my refrigerant gauges over here. I'm going to watch my amperage on startup, and all this tells me if everything's running okay. I know looking at my nameplate on my unit, my total amperage on the hottest, most difficult day for this unit is going to be about 28 amps. So I'm expecting something less than 28 amps. If I get something closer to 50, I know I'm about to blow my fuses and I want to shut it off and start checking out what's going on. So let's start it up. So there's startup. See my amperage draw is about 16 amps on that leg. you look on my other leg, 22 amps on that one. It's kind of odd, not sure why that's higher. Maybe just the little magnetic field around it's a little confusing. I can also change to voltage on the fly. Take my meter probes, 243 volts. This being a contactor, I can check both sides on L. Let's see, that's L2. Should be 0 voltage difference. Check my other side. Across the closed contact, it's also 0, so I know that's operating right. So that my voltage at the outlet of my contactor should be about 240 also. Should be the same voltage going in, going out. Okay? Go back to amperage. Verify my amperage is doing okay. I can check my gauges at this point, verify pressures, superheat, subcooling, etc. All right, last thing I want to show you guys the circuit breaker. This is the breaker panel and meter on the side of my house. Open up the panel. See all the circuit breakers are all labeled. They're not always labeled, but these particular ones are. If you see the air conditioning, look at that circuit breaker. It's rated at 50 amps and it's on. I already took the screws out of here. This is my main circuit breaker. It's 200 amps. Carefully take this off. All right, so with that off, you can see the wiring, pretty typical. Not as pretty as some, but good enough. See my bus bar for my neutrals on this end, bus bar for my grounds on this end, my L1 and L2 coming into the house, circuit breaker with the black and white wires coming off would go out to a conduit, and that conduit would go out to the side of the house where my electrical comes out for the condensing unit, and then from there through conduit into the disconnect.